Okay, this is 9.4 homework help. The first problem gives us a sequence here. A sub n equals 8 over 3 to the n. I'm going to rewrite this as a sub n equals 8 times 1/3 to the n. Just to show you that this is our standard geometric sequence. Now usually I write it like this, but it doesn't matter. We can start at n instead of n minus 1. It's a geometric sequence where we're multiplying each time by 1/3 to get the next term. So if we want to get the fifth partial sum, now I know this is technically series now, the sums, which is in the next section, but we're going to start covering it now. So we could start making a table. You know, the first term gives you 8/3. The second term, you're multiplied by 1/3 each time, so you get 8/9, and you get the idea. And I could add up those 5 terms together if I wanted. The calculator, we can do this a little bit quicker and easier. There's also a formula on the formula sheet, but in the calculator, we're going to go to alpha window, and we're going to do summation, which is 2. We're going to write this in summation notation. In summation notation, we would write the sum as n goes from 1 to 5, because we're adding the first 5 terms of the sequence right here. So that means we're going to add up the first 5 terms of this sequence. In the calculator, I'm going to use x instead of n, go from 1 to 5, and then I'll even put this in the fraction notation here, n over d, 8 over 3 to the n, or x power. If I hit enter, that's going to give me my answer for the first 5 terms. I'm going to hit math decimal here. You can enter that as a fraction or as a decimal, but as a decimal it's about 3.984. Now another way to do that is right here on the formula sheet. You'll see this nth partial sum formula, which tells you to take the first term, multiply it by 1 minus the rate, which in our case is 1/3 to the nth power over 1 minus 1/3. And that's what the next question asks us to do, because they want the nth partial sum. So we're going to have to use that formula. Here's the formula. Now we can just plug in. The first term is 8/3 times 1 minus 1/3 to the nth power, all over 1 minus 1/3 is 2/3. And then I'm going to move that to the top and multiply by 3 over 2 instead. And that way the 3's cancel and 2 goes into 8 4 times. So I'm going to rewrite this as 4 times 1 minus 1/3 to the nth to simplify it a little bit. Now to enter this in, I'm going to have to enter it in using a bunch of extra parentheses like I did here. 1 minus 1/3 to the nth, so that 1/3's in parentheses, and I'm raising that whole number to the nth power. And for some reason it looks like I included the same problem as problem 2 on accident, so sorry about that. Okay, the next problem wants to list the first 5 terms of the sequence. Now we can do this by hand, obviously, just by plugging in 1. You get 4 times -1 over 1 factorial, which is just 1. So the first answer obviously gives you -4. You can also do this pretty easily in your calculator. If you just plug this into y equals, use x instead of n. And then if you go to your table, so go to second table set, and start your table at 1 and go by increments of 1, then the first 5 will be right here for you. So there's your first 5, -4, 2, -2/3, 1/6, and -1 over 30. I think that's a little quicker than having to type all of them out by hand. Okay, the next question asks, is this sequence increasing, decreasing, or neither? Well, if you think about, just look at it and think about what's happening here. As you plug in n, this value is going to go to 0 as n gets big. So that doesn't help us at all. But this value n here is going to go off. It's going to diverge. It's going to go off to infinity. So because your n's getting bigger and bigger, and you're multiplying by 2, so that's going to go off to infinity. So when it says increasing, decreasing, or neither, it's definitely increasing. And then is the sequence bounded or not bounded? It's definitely not bounded, because, like we said, it's going to go off to infinity. All right, the next problem then, it gives us this recursive defined sequence, and it says we start with 1. So if we start with 1, that's our first term. First term is 1, they tell us. This tells us then to take the term and the previous term, multiply by 5, and add 9 to get the next term. So each time we're going to multiply by 5 and add 9. So that'd be 1 times 5, which gives you 5, plus 9 is 14. So each time we're going to do that to get the next term. We're going to multiply by 5 and add 9, which gives us this as our first 6. All right, the next problem wants a recursive relationship here. And they want us to use f of n minus 1 instead of, usually I use a sub n minus 1 to define the previous term, or sometimes g sub n minus 1 depending on if it's arithmetic or geometric. But it doesn't matter what you use. We can use that to describe the previous term. The first term's 2, and we got to figure out how we can get each of these terms. So it turns out with mine, if I multiply the previous term, which in this case is 2, but I'll use f of n minus 1, by 2 and then subtract 1, that's what I need, because if you start trying this, 2 times 2 is 4. 4 minus 1 gives you 3. And if you try it with 3, plug 3 in for the previous term, that'll give you 6 minus 1, which is 5. So just try some simple operations, basically. I tried multiplying by 2. I tried adding 1, multiplying by 2, or, just try some things. It's not going to be hard to get your recursive relationship here. Next question just wants to know if this sequence is arithmetic. It is, because I'm adding 3 each time. So my common difference is 3. I know you've learned this in the note video, but just a reminder, arithmetic is when you're adding something, it's the same number each time, and geometric is when you're multiplying by the same number each time. Okay, the next question wants to know if this one's arithmetic, and that's no, so I don't have to answer these questions. I have to add the same thing each time to get arithmetic, and this one is increasing the denominator of this fraction, so you start with 1/10, and then if you plug in 2, you get 1/18, and if you plug in 3, you get 1/26. You can try, subtract to find out what the common difference is if you were adding. You'll find it's not the same number. If you were to add that number to 1/18, you wouldn't get 1/26. So this is not arithmetic. Okay, the next problem says find the first term and the common difference of this arithmetic sequence, where it gives us the 8th term. So if this is your n, a sub n table, it gives us the 8th term down here, which is 20, and it also gives us the 13th term, which is 25. You can, if you want, 9, 10, 11, 12, you can just sort of count back, and you're going to find you're going by ones, 21, 22, 23, 24. There's different ways to do this. Another thing you can do is find the slope. Look at these as ordered pair, 8, 20, and 13, 25, because the slope is going to be, in this case, 25 minus 20 over 13 minus 8, which is 5 over 5, which is 1. The slope is going to be the common difference in this case, because if you reduce this to 1, then you're saying there's always a 1 in the bottom, which is what we want, because it's saying how much do we increase for each term. So how much do we increase the y value for each 1 increase in n, which will be the common difference. So now our formula for arithmetic is the first term plus n minus 1 times the common difference. So now an easier way to do this is, we know d is 1. So now we can just plug in one of the ordered pairs they gave us to find the first term. So I'll use the first ordered pair right here, 8, 20. So plug in 20 for a sub n, plug in 8 for n, in which case this will be 7. Subtract 7 from both sides, and we get 13 for our first term. So first term is 13, and we know the common difference is 1. Next problem wants us to write this arithmetic sequence in standard form. So once again, it's the first term plus n minus 1 times the common difference off the formula sheet. So first term is negative 17, and then it's n minus 1 times the common difference, which we're subtracting 4 each time. So that should probably work. You also can simplify this if you distribute the negative 4. So it'll be negative 4n plus 4, and then we can write it like this, negative 4n and negative 13. So here's, I guess, a better way to simplify it and write it. Next problem wants us to use the graphing calculator, so we can just plug this in to the calculator as I like to do the alpha fraction, 23 over n, so I'll use x instead of n. Then just go to your table set and make sure you, go to your table set, make sure you start at 1 and go by ones, so that way when you look at your table, it'll look just like the value or the table we would want for our arithmetic sequence. First term is 23. We can then scroll down to the 9th term, which is 23 over 9, and the 10th term is 23 over 10. Okay, the next problem gives us this sequence, and it says the first term, if we're looking at n and a sub n table, first term is 1, it says the second term is 15, the third term is 45, and the question is, what term number, n, question mark, is this the value 2,657,205. Now, it looks like we're multiplying by 3 each time, and that's important because we can start to write our geometric, which I like to use G for. You can use A if you want. But here is the formula that I use off the formula sheet. The first term is 5. The common ratio we're multiplying by is 3. So this will give us all the terms. So if you plug in 1, you're going to get 5. If you plug in 2, you're going to get 15. So that's what we want to use. Now the question is, what is term number is this? So we're going to just fill in this for our y value, 2,657,205, and we're just going to solve for n. Divide both sides by 5 first, and you get this. And then I would write it in log form, log base 3 of the 531,441 equals the exponent, n minus 1. Now just add 1. So all I have to do is do this in my calculator and add 1. So that's alpha window log base is 5, log base 3 of this big number, and then just add 1. And the answer is 13. So that means it's the 13th term down here. So if I were to multiply by 3 13 times, that gets to this number. Okay, the next problem gives us a geometric sequence, wants the ratio. So the question is, what am I multiplying by each time? One thing you can do is just write it. If you're not sure, if it's too complicated for you to see, just write it out, write an equation. What am I multiplying 8 by to get 16 over 5? And you can just divide both sides by 8 or multiply both sides by 1 over 8, and you get 2/5. So my ratio is 2/5, and you can see that's what it is. That's what I need to multiply by each time. And so now they want to know the 5th term. Well, it might help to write out the sequence. The first term is 8. The ratio is 2/5 to the n minus 1. So the 5th term is what I get when I plug in 5. So it'll be 2/5 to the 4th times 8, which I can do right in my calculator, and that gives 0.2048. And the next question, what is the nth term? Well, that's just asking for the sequence. There's our nth term right there. And there's different ways you can write this, but for now, let's just leave it just like this. Next question wants us to find the nth term of the geometric sequence, and it gives us the initial term is 0.5, so that's g sub 1. And it also gives us the common ratio is 9, so we can plug that in right at the formula off our formula sheet. First term is 0.5, ratio is 9. This will work just fine. All right, and then the last problem wants us to know if we can do the infinite sum of this. Now we do have an infinite sum formula in the formula sheet, but it only works for r values that are between -1 and 1, basically. So let me show you that really quickly. Here is the formula sheet. Here's the infinite geometric series right here. If our absolute value of r is less than 1, so basically if r is between -1 and 1, then we can use this for our infinite converging geometric series, which I know is technically next section, but our r is not between -1 and 1. 5/3 is bigger than 1, which basically means that you start off with 4 times 5/3, so you start off with 20/3. Actually, this thing starts off at 0, so you start off at 4. And then if you plug in 1 for I, then you get 20/3. And you're multiplying each time by 5/3. So then you get 100 over 9. And basically you can see these numbers are getting bigger. So this thing is doesn't converge. Therefore, when I'm looking for the sum, it does not exist, because it's just going to go off to infinity. If you keep adding, if you add these up, this number is getting bigger. So you're just adding up a bigger number each time, and it's going to go off to infinity. All right, I hope this helps.